Okay, so in question 23 what we have is in a geometric series t1 equals a and t2 equals a squared minus 2a. If it's a geometric series, the common ratio equals t2 divided by t1. So we can see that t2 is a squared minus 2a and t1 is a. Then we're going to have a into a minus 2 all divided by a. The a's cancel. And what we're left with is a minus 2. Remember, this a has nothing to do with the first term. Or it does actually, because the first term is a. Now, write down in terms of a, the common ratio of the series, that's a minus 2. Okay. Then, the sum of affinity is 5. Find the value of a. Well, the sum of affinity, or S affinity, equals a over 1 minus r. And if it's a over 1 minus r, it's going to be a divided by 1 minus a minus 2. And that's going to be equal to is a over, now that comes at plus 2, so it's going to be 3 minus a on the bottom. Okay, and we know that this equals 5. We're going to cross multiply up, and we're going to get a equals 15 minus 5a. And then bring it over to your side, so we get 5a plus 1a equals 15, 6a equals 15, then a equals 2.5. Okay, so a equals 2.5. Find the range of values for a element r for which the series has a sum to affinity. Now remember, a sum to affinity only exists when your r value or your modulus of r value is less than 1. Okay, so there's two values here. Okay, r, you could write down r is smaller than minus 1. R is bigger than minus 1 or smaller than 1. R bigger than 1. Bigger than minus 1. Or r less than minus 1. So we have for r is a minus 2, so we know that a minus 2 is greater than minus 1, or a minus 2 is less than minus 1. Bring the 2 over the other side, and we get is a is less than 1, that's going to be plus 2, or we bring this 2 over the other side and we say that the other one's going to be a is less than 1, not less than minus 1. So it's a is less than 3, or a is greater than 1. So a greater than 1, a less than 3. This can also be written as 1 is less than a. We know that a is less than 3. Then you can join the two of them to make the one inequality of 1 less than a less than 3. Any numbers between 1 and 3. Okay, so now we're on question 4. Question 4, right? The sum to affinity, that's what this means here, the affinity sign, where you start off, your first term is u0, you replace n with 0, okay, of 1 divided by 1 minus x to the power of n, equals x squared plus x squared over 1 minus x plus x squared over 1 minus x squared is an infinite geometric series. Find in terms of x the common ratio. Well, the common ratio, once again, would be call that t1, which is the first term divided by the second term, even though it technically starts at u0 and u1. So u1 divided by u0, or it's the same thing as t2 divided by t1, okay? So what we have here is x squared divided by 1 minus x, all divided by x squared. Bring the x squared up, and then comes 1 over x squared. And then when you divide them in, what you're going to get is the x squareds cancel. And the common ratio is 1 over 1 minus x. Right, so that's the common ratio. Now to find the sum of affinity. Sum of affinity, or S affinity, equals a into 1 minus r. Okay, and what that is going to equal, your a value is your first term in your sequence. A value is x squared. So a equals x squared divided by 1 minus bracket 1 minus x. And that is going to equal x squared x. I think it's x squared over x because equals x squared over x because it's going to be 1 minus 1 plus x, and the 1 minus 1 on the bottom cancels, and that is going to equal x. The sum of affinity is x. Sorry guys, excuse me, I actually made a mistake there. The actual common ratio, sorry, is 1 over 1 minus x, excuse me. So we're going to get lowest common denominator, which is x squared over, now this here is over 1, so we need to get them the same denominator. So it's going to be 1 minus x over 1 minus x. It's the same thing as 1 minus 1 over 1 minus x. So that's going to give me x squared. And then on the bottom I'm going to have it's going to be 1 minus x minus 1. So 1 minus x minus 1 all over 1 minus x. So 1 minus common ratio. So what we get here is going to be x squared divided by, on the bottom we're going to have minus x divided by 1 minus x. We got to bring that up, turn it upside down. So we're going to have is x squared multiplied by 1 minus x divided by minus x. So minus x into x squared leaves me minus 1. X divided by minus 1 is minus x. Minus x into 1 minus x multiplied out, and what we get is x squared minus 1x. Okay, so that's your sum to affinity right there. Sum to affinity, S infinity, is x squared minus 1x. The next question says the sum of affinity is 30, find the values of x. Well, the sum of to affinity is x squared minus 1x, that equals 30. Bring the 30 onto the other side. I'm going to get x squared minus 1x minus 30 equals 0. Then we're going to get x minus 6, x plus 5 equals 0. X equals minus 5, or x equals 6. That's x minus 6 equals 0. Bring it over to your side. Then, so that's it there. Okay. The sum to affinity of a geometric series is 27, and the second term of the series is 6. Find two possible series. So remember, Tn equals a or n minus 1. So T2 is basically a or n minus 2 minus 1, which is a r. Okay. Sum to affinity is a into 1 minus r, and that equals 27. And then what we're going to get is a equals 27 minus 27r when we cross multiply it. Now, what we know about T2 is 6, so that means that a equals 6 over r. Replace in 6 over r for a. 6 over r equals 27 minus 27r. Cross multiply. And what we're going to get is 6 equals, just give them a common denominator. So put an r underneath here, that's r squared. Put an r underneath here, r up here. So we're going to get 26 equals 27r minus 27r squared. Move it over to your side. 27r squared minus 27r plus 6 equals 0. Okay, so the try here is probably the minus b formula. Or minus b form. A equals 27, b equals minus 27, c equals 6, minus b plus or minus square root of b squared minus 4ac all over 2a. So we're going to get is plus 27, because minus b equals plus 27, plus or minus the square root of b squared, which is minus 27 squared minus 4 times 27 times 6 all over 2a, which is 2 times 27. So we're going to have is 27 plus or minus square root of minus 27 squared minus 4 times 27 times 6 turns out to be 9 all over 54. So we're going to have 36 over 54, or 18 over 54. And 36 over 54 26 divided by 54 is 2/3, so r equals 2/3, or r equals 1/3. Okay, so there's our two. Find two possible series, right? So the two possible series are r equals 2/3, r equals 1/3. Now I have to find out the a values. So a equals 6 over r. A equals 6 over r. So 6 divided by 2/3 is going to be an a value of 9. And then finally a equals 6 divided by 1/3 is going to be an a value of 18. So there's your two terms there, your two series. Okay, so to write down the series, we're going to start off with 9, and then we're going to multiply by r value of 2/3. So 2/3 of 9 is 6, 2/3 of 6 is 4. That's series A. And series B is 18, gets multiplied by 1/3, which is 6. 6 gets multiplied by 1/3, which is 2. There's your two series there. Okay guys, moving on to number 28. The ball is dropped onto level ground. It takes 1 second to hit the ground, and 80% of that time to rise to its new height. It continues to bounce at a rate until the ball comes to rest. How long does it take to hit the ground for the second time? So the ball bounces. It takes 1 second, and then it rises to 80%. It takes 80% of that time to rise back up. So it takes the same amount of time to come up as it does to come down. So it takes 80% of 1 second, which is 0.8 of a second, to hit the ground for the second time. Okay, so that was actually 0.8 seconds more. So let's do, okay, so when the ball is dropped, it takes 1 second. So when the ball is dropped down, it takes 1 second. Then when it comes back up, it's 0.8. And then it goes back down 0.8. So when you add them together, it's actually 2.6 seconds in total for the ball to come back down again. Okay, write down the times for each individual bounce as an infinite series. Write down the times for each individual bounce as an infinite series. Okay? So the hard part of this question is actually defining the bounce. On bounce 1, you go down 1 second, and you go up 0.8. So that there counts as 1.8 seconds. On bounce 2, you go down 0.8. And then you go up 80% of 0.8, and 80% of 0.8, 80% of 0.8 equals 0.64. So then you come up 0.64, and then on the third bounce you're dropping down 0.64, and you're going to rise up 80% of 0.64. So 0.8 of 0.64 is going to be 0.512, and then you add them together. So what we're going to get here is 1.44, and then add that to 0.64. And you can see here is it's 1.152. So that's our series there. Okay. How long does it take the ball to come to rest? Okay guys, so if we count this is T1 is the first bounce, T2 is the second bounce, and T3 is the third bounce, okay? So what we have here is a geometric sequence, because every single time the R value is 4/5. Okay? And what we need to do is get the sum of... Okay guys, so the last question is basically how many bounces does it take for the ball to come to rest. Use the sum of infinite series, so you're going to find out what happens when the time gets smaller and smaller and smaller and you're adding them all together. Okay, so what this is basically A into 1 minus R. The A value is 1.8, the R value is 1 minus 4/5, and then we're going to get 1.8 divided by 1/5, and the sum of the infinite series is 9 seconds.